So, good evening, class. In the series of Fundamental of Maths, yesterday we were discussing about the normal form of the equation of the line, and secondly, we had discussed about the circumcenter and the incenter. So, today we will be discussing one of the important topics of the coordinate geometry, which is the distance between the two parallel lines. The first and foremost, what is the parallel line? Parallel line, as we had already studied in our lower classes regarding this concept, that is parallel line, that it is a locus of 2 points, such that whenever the path is traced by these 2 points are at the same distance, and this length will continue up to infinity. The points will be at the same distance and it will continue up to infinity. That length will be stretched up to infinity. That is the parallel line. And I will just show what is the main concept line is. Suppose these two points are there. When they will trace a path, when they will trace a particular path, and when they will trace a particular path, suppose this point, it is moving in this direction, and this point, it is moving in this direction. So this is the path traced by both the points. This path may be in the unidirection or this path may be in the opposite direction, no issues, but they will be called as a parallel line. And the distance, the main concept, the underlying concept between these two parallel lines is such that the path traced by 2 points in such a way that the distance between these 2 points, distance between these two lines will be constant and will be equal up to infinity. That is the parallel line. This type of concept, then this type of geometric figures or geometric alignment is termed as a parallel line. Okay, so the first and foremost, whenever we are talking about the slopes of the parallel line, the slopes of the parallel line will be equal. No matter what is the concept between that, but it is universal that the slope of the parallel lines will be equal in each and every aspect. Whenever the two lines are mutually perpendicular to each other, then in that case the product of slopes will be -1. That is, m1 into m2 is equal to -1. Whenever the lines are parallel to each other, then in that case their slopes will be equal. That is, m1 is equal to m2. So in this case, as far as the distance between the two parallel lines are considered or concerned, we have drawn two axes. The name of the axis is entitled as x-axis and the y-axis. The horizontal axis is the x-axis and the vertical axis is the y-axis. And we have taken two lines, and those lines are entitled as ax plus by plus c1 is equal to 0 and ax plus by plus c2 is equal to 0. We have taken the coefficients of x and y, both are same. Both the magnitude of the coefficients are same. That is, a here also and here also it is a. In the case whenever we are talking about the coefficients of y, both are same because these two lines are parallel to each other. So whenever we want to calculate the slope, the slopes will be equal until and unless the coefficients will be equal. The slopes will be equal when the coefficients will be equal. So we had drawn the two parallel lines. We had taken the coefficients to be equal. Both the coefficients of x and y are equal. Now we will be applying the basic concepts of the geometry. Okay. So first and foremost, we will take a point. That point, the coordinate of that point, the location of that point in the particular space will be hk, and that point will lie on the first parallel line. This is the first parallel line and this is the second parallel line. So this point hk will lie on the first parallel line. Ax plus by plus c1 is equal to 0. As we had already studied in the earlier concept of the coordinate geometry, in the earlier classes of the fundamental of maths, that whenever a point lies on a particular line, that point will satisfy the equations also. That point will also satisfy the equations also. So whenever we will put hk in the place of x and y, we will be getting ah plus bk plus c1 is equal to 0 because that particular point will satisfy the equation. So AH plus BK plus C1 is equal to 0. So we will transfer the coefficients. AH plus BK we will keep one side and we will transfer the coefficient minus C1 to the other side. So we had got AH plus BK in the terms of minus C1. Now we will take this point HK and this point P. We will join this P to N, that is NP, and we will calculate the perpendicular distance. The perpendicular distance between these two, the perpendicular distance from this point to this parallel line will be the distance between the two parallel lines. So we had, first and foremost, we had formed one equation which is in that form of C1. Now, as per the distance between the two lines formula, the distance between the two lines state that it is whenever we want to calculate the distance from a point x1 y1 to the equation ax plus by plus c, then the formula is ax1 plus by1 plus c1 by under root a square plus b square. So we had used the same concept here. We had taken the point hk and we had multiplied the coefficients here. This is the second term equation. We have to take this equation now. So ah plus bk plus c2 by under root a square plus b square. The same formula which we had deduced earlier using the concept of the, you can say, the whenever the point is there and that perpendicular distance whenever we have to calculate, then in that case we have to use this particular formula. So we had substituted the values of h and k and we had formed this formula ah plus bk plus c2 by under root a square plus b square. Now we had already deduced one equation ah plus bk is equal to minus c1. Now in the place of ah plus bk we will substitute minus c1. Already plus c2 is there, plus c2 will be there by under root a square plus b square. For our convenience, we will take C2 first, C2 minus C1 by under root A square plus B square. So it is the distance between the two parallel lines. It is the distance between the two parallel lines. So this is the complete procedure for finding the distance between the two parallel lines. So after this, we will be taking some examples which will render more transparency on the concept which I had taught. Okay, so we will be taking some examples. It will be easy for us to understand the concept. So we will be taking the main basic questions so that it will be easy for us to understand the concept. So first and foremost, we have to take two parallel lines. In the question, there will be some 2 to 3 types of question which may come in the examination regarding this. We will see some types of the question. Type 1. In the type 1 question, suppose there will be two parallel lines. Direct question will be there. There will be two parallel lines. In that case, we have to calculate the distance between the two parallel lines. So it is 2x plus 4y plus 7 is equal to 0, and the second will be, suppose it is 4x, 2x plus 4y plus 7 is equal to 0, and it is 4x plus 8y plus 16 is equal to 0. So suppose we have to calculate the distance in this question. So we will be starting the question like this. Suppose it is 2x plus 4y plus 7 is equal to 0. We will take 2 in the equation 2 common. We will take 2 common. 2x plus 4y plus 8 is equal to 0. Now this will transform into 2x plus 4y plus 8 is equal to 0. Now in this case, A is 2, A is 2, B is 4, B is 4, C1 is 7 and C2 is 8. So we will just write here 8 minus 7 by under root 2 square plus 4 square. It will be 1 by 16 plus 4, 20. 1 by under root 20. So this is the type 1 question. This is the simplest question in which there will be there will be a direct question that we have to calculate the distance between the two parallel lines when the coefficients will be given, and we have to calculate the distance between the two parallel lines. The constant may differ, but the coefficients will be equal because we are taking the parallel lines into consideration. The second type of question will be, suppose in this we will be asking that a parallel midline is there, and the distance between the parallel midline is there, and we have to calculate the distance of that parallel line with the first one, and secondly we have to calculate the distance between the mid parallel line with the third one. So that is also another type of question. So as of now we had covered this concept, the distance between the two parallel lines, and we had completed this topic. We had gone through some of the types of question which may come in the examination. So this is all about the distance between the two parallel lines. So from tomorrow onwards we will be covering an important topic of the coordinate geometry, that is circle. So please observe the video, see the video, like it and subscribe it. If you have any issues, please do comment on the comment box, so that I will be receiving an intimation on the regular basis what type of difficulties you are facing with the associated with this topic, and I will try my best so as to resolve the query within the shortest possible time. So for today we had completed the distance between the two parallel lines. Thanking you for the day. Have a nice day. Good night.